The world's largest source of recycled steel doesn't come from mines, but from the auto recycling industry, often called the car's second gateway. This $60 billion industry supplies a massive and stable stream of steel while creating hundreds of thousands of jobs. In the United States alone, more than 12 million vehicles are dismantled and recycled annually, effectively turning scrapyards into some of the most efficient steel mines ever created. Recycling one car saves up to 74% of the energy compared to mining new ore, and an average of 75% of a vehicle's weight can be recovered. Steel, aluminum, copper, plastics, glass. Automobiles are, in fact, the most recycled consumer product in the world. Over 95% of end-of-life vehicles in the US are recycled. The process of regenerating an old car follows a systematic sequence of steps, ensuring safety and maximizing the value of recovered materials. Technicians record the VENG, overall condition, and paperwork. The first step is removing the battery, lead acid or lithium-ion. And extracting all remaining fluids, gasoline, oil, coolant. These fluids are filtered and reused as in-house operational fuel, which helps cut energy costs and prevents pollution. Major components are stripped from the vehicle. Wheels, tires are processed into rubber granules, metal rims sent for melting. Windshields, glass and PVB layer recovered. And interiors, copper from wiring, plastics, and fabrics retrieved. The engine and transmission are separated. Some are refurbished for resale, while others are broken down further to extract aluminum, steel, copper, and precious metals from the catalytic converter. The bare steel frame is moved to a rough processing area to remove problematic materials like exhaust pipes, plastic panels, It is then fed into a hydraulic press 1,502 tons, compressing it into dense metal blocks. The metal blocks are loaded into a high-capacity shredder, where massive counter-rotating shafts tear them into uniform fragments. A modern shredder can process up to 150 tons of steel per hour. The mix of metal fragments travels along a sorting line where powerful magnets pull out carbon steel, and eddy currents deflect aluminum and copper. Once sorted, the pure steel scrap is ready for its next life, beginning with high-tech metallurgy. The purified steel scrap is charged into the electric arc furnace. Here, graphite electrodes discharge a high-intensity current, creating a blazing electric arc that rapidly pushes temperatures past 1,600 degrees Celsius, melting the metal into a stream of liquid steel. During this process, lime and flux are added to gather impurities like phosphorus and sulfur into a layer of slag floating on the surface. Sensors and spectroscopic analysis systems continuously monitor the chemical composition to ensure the alloy quality meets strict standards. The refined molten steel is channeled into a continuous casting line. The liquid metal flows into water-cooled molds, solidifying its outer shell in seconds, and is pulled out as long billets, metal bars. These billets are cut into standard segments, ready for the next stage. The glowing red steel billets are fed into the hot rolling mill, where dozens of massive rollers continuously press, stretch, and bend them into uniform sheets or coils with high precision. After rolling, the steel is cooled in a controlled manner, then checked using ultrasonic sensors and tensile strength testers to ensure zero defects.